Ever needed to adapt a generic search function into something more specialized without rewriting the entire tool? We'll take a basic database search tool and transform it into a domain-specific product search just by changing its metadata. You'll see how Tool from Tool lets you customize names, descriptions, and even argument behavior while keeping the original logic intact. From FastMCP, import FastMCP. From FastMCP tools, import tool. MCP equals FastMCP. Hash the original, generic tool. At MCP, tool. Def search query. SDR category, SDR equals all, list dict. Searches for items in the database. Return database, search query category. Hash create a more domain-specific version by changing its metadata. Product search tool equals tool from tool. Search. Name equals find products. Description equals search for products in the e-commerce catalog. Use this when customers ask about finding specific items, checking availability, or browsing product categories. MCP, add tool, product search tool. This demonstrates the tool transformation pattern, a specialized form of the adapter pattern for AI-integrated systems. The technique creates domain-specific interfaces by wrapping existing tools with modified metadata or behavior without altering the original implementation. What makes this distinctive is its focus on LLM compatibility, transforming technical APIs into natural language interfaces through declarative metadata changes rather than code duplication. The pattern works by establishing a clear separation between core functionality and interface presentation. A base tool contains the implementation logic, while transformed versions adapt that logic for specific contexts through metadata overrides or lightweight wrappers. This declarative approach allows you to modify names, descriptions, argument schemas, and even behavior while maintaining a single source of truth for the underlying logic. This approach solves the common problem of API misalignment between technical systems and LLM expectations. It enables you to expose the same backend functionality through multiple tailored interfaces for different use cases, reducing both boilerplate and maintenance overhead. The trade-off is a slight runtime indirection cost, but the benefits in interface flexibility and code reuse typically outweigh this for AI integration scenarios where interface clarity is paramount. Let's break it down. From FastMCP, import FastMCP. From FastMCP tools, import tool. Imports the core FastMCP class for creating AI callable tools and the tool class for customizing tool metadata. These are the foundational components for exposing Python functions to AI models with controlled behavior and descriptions. MCP equals FastMCP. Instantiates the core FastMCP controller. This is your central registry for all AI callable tools, handling tool discovery, validation, and execution routing. Hash the original, generic tool. At MCP, tool. Def search query. SDR category, SDR equals all, list dict. Searches for items in the database. Return database, search query category. This defines the base search function with @MCP tool, exposing it as an AI callable tool. The decorator converts Python type hints and docstring into a structured schema that AI models understand, while the function itself delegates to a database search implementation. This generic version gets specialized later for domain-specific use cases. Product search tool equals tool from tool. Search. This creates a specialized tool by cloning the original search function. The from tool method preserves the core logic while allowing custom metadata, enabling domain-specific tool variants without code duplication. MCP, add tool, product search tool. This registers the specialized product search tool with the FastMCP instance, making it available for AI model invocation. The registration step is required. Without it, the tool exists in code but remains invisible to the AI system. This follows the explicit registration pattern, ensuring only intentionally exposed tools are callable. Tool transformation pattern. The tool from tool method creates domain-specific interfaces while preserving the original implementation, enabling one function to serve multiple specialized purposes without code duplication. Disabling the original tool prevents LLM confusion when similar tools coexist. But remember, this only affects visibility, not the underlying function's availability in Python. This approach maximizes reuse while maintaining clear, purpose-driven interfaces for different contexts.
The tool that forgets its name remembers every purpose